friends, this is Bright here. In this video, I am going to illustrate the data structure stack using Python. And my editor is PyCharm. This is a version which I am using. And here I am going to demonstrate the concept by using class and object concept. So I am creating a class called a stack and overriding the init method with a keyword argument called a limit, and I am setting it as 5. So this limit is going to be the maximum size of the stack. For that, I am going to say that self dot max size equal to limit, and I am going to bind an instance attribute called my stack, and this is going to be a list where we are going to perform the operations of the stack: push, pop, pick, and so on. And one more attribute I am going to bind called top. I am setting it as -1. So whenever an item is added to the stack, the top will be incremented. Whenever an item is removed from the stack, the top will be decremented. Now I am going to create some auxiliary functions to check whether the stack is full or not, or the stack is empty or not. So let us see that a function called isFull. The purpose of isFull function is whenever we want to add some data to the stack should not be full. As I mentioned earlier, whenever we add an item into the stack, top will be incremented. So for the first data, top becomes 0. When you add a second data, top becomes 1. So if there are 5 data in the stack, and we are assuming that maximum size is 5, what will be the top value? Top will be 4, because 0 to 4. So we can say that return true if self dot top equal to 4. Sometime we will pass some explicit value. Let us say 10 is the maximum size. Then it should be 9. So we can say a generic statement self dot max size -1. Else it should say that false. False means it is not full. Similarly, for removal operation or for pop operation, we have to check whether stack is empty or not. If the stack is empty, we should not allow the pop operation. For that, another auxiliary function define is empty. We can say that return true if self dot top equal to -1, because in the init we are creating a list. At that time we are saying that the top value is -1. It means the stack is empty. So return true if self dot top is equal to -1. Else false. Now we are going to create the push function. For that, I am naming it as push item. So when you call the push item, we will pass an input also to be pushed or to be inserted. For that, let us say item. But before adding the item into the stack, check whether the stack is full or not. For that, we can say if it is not, full. So when you read it togetherly, if it is not full, we can add the item to the stack. For that, we can say self dot top. For that, we can say self dot my stack dot append. Since my stack is a list, we can call the function append to add the item that will be inserted to the end of the stack. Append which item to be added. And also we have to update top by saying self dot top plus equal to 1. What about the else condition? Else means the stack is full. We can give a friendly message to the user that it is overflowing status. And next we are going to see a function that will be popping out the elements from the stack. For that, define pop item from the stack. And here no need to pass any input, because when you call pop item, the topmost element should be removed from the stack. Now we have to check whether stack is empty or not. For that, we can utilize this auxiliary function is empty. So if not self dot is empty, so if it is not empty, remove the topmost element from the stack. Self dot my stack dot pop function. And also we have to update the top. For while adding the data, top should be incremented, and when we remove the data from the stack, we have to decrement it. So self dot top minus equal to 1. But if the condition doesn't satisfy, it means the stack is empty. We can give a friendly message to the user that underflow. Now I am going to create another function called peek. The purpose of peek function is to display the topmost element from the stack. Again, we have to check the stack is empty or not. If the stack is empty, we cannot display. So we can say if not self dot is empty. If it is not empty, print the topmost element from the stack by passing the index value -1. So it will access the data from the end of the list. So else means the stack is empty. We can give a friendly message that stack is empty. And I am going to add one more function to see the status of the stack at any time. So define status. Just say that print self dot my stack. If it is empty, it shows an empty list. If it is not, whatever data is available there, that will be displayed. And now I'm going to create an object for the stack. So before that, a quick overview over all the functions. So initially we have the init to set up the basic things, then isFull function. So if top is equal to maximum size minus 1, say that it is full, otherwise else false. Similarly for MD, if top is equal to minus 1, return true, otherwise return false. Then for push item, if the stack is not full, add the item to the stack and increment top. If the stack is not empty, pop the element from the list or stack, then update top, where peak displays the topmost element from the stack. Then status, it shows the status of the list or status of the stack. And now creating a stack object, let us say s is equal to stack, and I'm not passing any data here. If I pass 10, then 10 will be the maximum size. If I don't pass anything, maximum size is 5 by default. I'm going to use an infinite while loop with menu driven option. For that, I'm using a print function with various options such as 1 for push, then in the next line option 2 for pop, next line option 3 for peak, new line option 4 for status, then last option 5 to exit from this infinite while loop so that our loop becomes finite. So we have to get the option from user. For that, I am using a variable called option. Get the input from the user by using input function. We can say that enter your option, and if required, you can give a white space after that. Then we have to check the option whether it is equal to 1. So I am doing a numerical comparison. For that, this option should contain an integer value. So convert this into integer, here open parenthesis and here close parenthesis. So if option is equal to 1, perform the push operation. We can say push item and the data to be inserted into the stack. So if I write directly like this 100, every time for every push operation, only 100 will be inserted. So if we need some dynamic input, replace this 100 or constant value by using the input function with a friendly message to the user, enter the data. And if required, you can give a white space. And else if, that is elif, option equal to 2, we have to say that pop the item from the stack, and if option equal to 3, show the topmost element, that is s dot peak, and if the option is 4, show the status s dot status. And next, elif option equal to 5 exit, or we can say for any other option come out. We can use a simple break statement that will terminate our while loop. Now let us see whether we are getting the expected output or not. So I am giving an option 1, enter the data. Okay, let it be 11. Yes. Now let us check the status 4. You can see a list with 1 item. Let me try to remove it. Option 2. So pop. Let us see the status 4. It is an empty list. Now the stack is empty. Let us try to apply the pop once again. 2. You can see it is giving a message underflow. It means the stack is empty. Pop cannot be applied. Now let us see what is peak. 3. It shows stack is empty. Now let us add multiple data. Option 1, let me give once again 11. Then again option 1 to add 12. Option 1 13. Option 1 14. Option 1 15. Now let us see the status. 4. We can see 5 data are available. Let us see the peak status. 3. Yeah, the topmost element is 15. Now let us try to add one more data, push. Enter the data 16. It shows that overflow because it can accommodate here maximum 5. Yeah, now option 5, exit. You can see the process is finished with exit code 0. So it is a normal termination. Thank you for watching this.